All right, this is a new lesson here on materials. So, my experience in my profession has led me both down the 2D and the 3D route, both painting in 2D, but also rendering and doing things in 3D. And since I work in animation, I find that we've had to kind of find some common ground in the terminology we use to talk about material, so that when an art director or a production designer is giving notes to a 3D artist, a lot of the times the 2D art director or production designer wasn't or hasn't always been tooled with the right terms to describe what the 3D artist is working with. For example, we just, as you see here, one of the common material attributes of albedo or color. Albedo now has become a very specific, almost scientific term used for 3D rendering and in texture mapping and kind of building up shaders, whereas for the average painter, or almost more than average, just even your production designer, art director, top level artist may not be too familiar with those terms. So I've kind of taken it as my own personal challenge, or kind of just my mission in life as a teacher, to kind of bridge the 2D and the 3D and kind of get us on the same page. And that will help you as you collaborate with 3D artists, or if you yourself are venturing into 3D as well, or you're more of a 3D artist coming into 2D. Whatever it is, this will help bring us into common ground. The other thing is, I find that as a 3D artist, when I learned 3D and rendering, I had to get a lot more scientific, or kind of be much more analytic of materials and how light reacts with them in order to simulate it in a 3D render. And so that's transferred in kind of into my 2D painting, where I can be a little bit more analytic and kind of understand better what it is I'm observing in real life, and therefore be able to translate it to illustration. So I've broken these down. I have 4 common material attributes. That means pretty much all materials have these, or most likely have a range of these attributes. The first one being albedo, or color, which is really just the measure of diffuse reflection of solar radiation. I don't want to sit here and read every one of these. I'll give this to you. You can pause, freeze frame this. You can read through it. Please do. It's a little, I know that it's, a bit heavy in the syntax being used, but I'm going to break this down in a very clear, simple way, one by one, and you won't have any questions by the end of this about what these terms mean or how to paint them. So let's just go ahead and just dive right into it. If we need to come back to this page, we always can. And first, let's just talk about albedo. So when light is broken up through a prism, we get all the different colors of light, and we can see that pure light or light rays have all the different colors. And so when light hits an object, say it hits a blue object, it absorbs all the other colors, but it reflects the blue light, right? These are different wavelengths. Black materials just absorb all the color. White materials reflect all of it. So that's why, it's actually reflecting the entire spectrum. And this yellow one. So that pattern carries out throughout all colors. And so when we paint the color albedo, I would say kind of just try to imagine what the color is minus any sort of rendering, any sort of light and shadow or reflections or highlights. And that's what we're talking about when we say albedo. So you can see on this wood sample, if I were to just have this wood swatch with no lighting at all, that is what we're looking at, albedo. And then everything else we can then build up and paint on top. We can actually put shadow on top of this. We can do our specular highlights and layer those in. A lot of artists will build their entire painting just pure albedo to begin with, right? Sometimes, more commonly, maybe it's just called their flats. Put in the flats, and then build in your rendering, your chiaroscuro, your lighting, and your materials and textures. Okay, so pretty basic, right? Let's go ahead and talk about reflectivity, and this gets a little bit... I usually break this out into two types of reflections, and that's because that's how I paint them. So when I'm talking about the reflection of the light source, that is often called a specular highlight. So the specular highlight, where people are referring to basically that little bright, shiny highlight. It's the light source, like the sun or a light bulb in a room. There could be multiple specular highlights, right? So if there's multiple key light sources, then those will get reflected. And then the other reflection that I break out is sort of the environment reflections, right? You might be reflecting a sky, some buildings, its own, even a cast shadow can be reflected into an object like a sphere. Now, when we talk about reflect the reflectivity of an object, by the way, in 3D rendering, this is kind of now called roughness. So roughness is sort of this new term, like how rough is your object? It works, even though that may not be the only factor in reflectivity. It's not just whether something's rough or smooth, and that's actually what I'm going to talk about here when we have, in this first example, you'll see I have less reflective to more reflective material. So in each of these cases, we're assuming the albedo is the same color. We're also assuming that the gloss is the same. It's the same amount of smoothness, right? One's not smoother than the other. But the material itself can be a more reflective material, like a metallic metal is more reflective than, say, paper. So if this is very smooth paper, but it doesn't have the reflectivity, then we can actually have quite a varying degree of looks. And so it's important to understand. So you can, generally speaking, things that are metallic, more reflective of a material, are going to have more contrast. So we're going to see, I've talked a lot about halfway to black. Metallic or reflective materials are going to push further than halfway to black because they are reflecting more of the environment and pulling more value into it. The second example here, when I say less glossy, sorry, that's we have a typo here. Let's go and fix that. Glossy. They both, okay, there you go. Less glossy to more glossy, but the same albedo and the same reflectiveness. So here the only thing that's changing is the surface is getting smoother or rougher. So on the left side we have a rougher where light gets diffused across the form. Think of a microscopic level. The light just hits the rough object and it gets scattered in different directions. Whereas a smooth object is going to just reflect directly back. It's gonna and it's going to lead to some stuff where we have sharper specular highlights. We're going to have sharper reflections. All right, so here we have this more glossy. So this is we would term matte, satin, and glossy, and then all the levels in between. Now this final example down here, we have darker albedo to lighter albedo. So we're actually changing the color, but we're keeping the same reflectiveness and the same gloss. So you can just sort of see how there's sort of three parameters being compared in this instance, where we're keeping two the same and we have one variable. And you can see the variety of results you will get from that. So you always want to be analyzing and asking yourself, like, okay, how reflective is the material? And there are like scientific numbers and things that go into how reflective a material like steel versus gold is. But then we're also looking at how finished is it, right? Has it been polished and smoothed? Is it still raw and rough? And then, of course, just the general color of it. Now, one thing about reflectivity as well is they can actually have a tint or a color to it. So if it's a gold, for example, everything gets reflected as gold. has a gold yellowish color. So here I have two more rendered elements. On the left hand side, what I'm showing here is that reflections, the environment has a very heavy impact on it. Even if all you're really, and oftentimes, we're not going to paint every reflection in an object, right? Because that just gets overwhelming and not necessary. Maybe if there's like some chrome spaceship, that's the hero spaceship, then we have to kind of consider more of the environment and paint all those reflections. But at a minimum, the specular highlights would be consistent. So here you see I have a rectangular shape specular highlight on the left, and on the right hand side I have three different ones. So that indicates that there's three light sources, maybe three different spotlights in the room or a chandelier of something. And then on the left hand side we have maybe a soft box lighting the scene. And so all of our reflections would take on that rectangular or square shape. Over here, what you're kind of seeing is the same gold sphere. One has been polished more shiny, so it has a more chrome look to it, so the environment is crisp and sharp. On the right hand side, it has almost, I can't think of the name of it right now, but where it's been blurred out. The reflections are more blurred. It has a different finish to it. So let me think if I can remember quickly the name of that term. All right, apparently it's not that complicated. They just call it a satin finish. Brushed would be another example. I'll show you what a brushed finish would look like on metal coming up here. Okay, cool. So now we have, we've talked about reflectivity. I've talked about albedo. Now I want to get into a topic we call bump. Now, this is definitely something that I would say is more, let me make sure I go to the right ones that I want to see first. Oh yeah, that was all of them. Okay. So, in 3D rendering, oftentimes we want to get high-level detail in a render, especially in video games, where we can make something feel bumpy and something's extruded, but we don't have to actually model it or have that geometry living in our scene or a video game, because that gets just too heavy and it reduces the performance for the video game or any render. So we use bump maps, and these bump maps kind of create the illusion that there's bumpiness to a surface. We also use normal maps, are a little bit more sophisticated. Essentially, they do the same goal in mind. But when we're painting, I think it's good for us to use as an analysis tool and also layer into our process that, okay, I've put this wood texture down. If I want to make it feel more aged, then I want to start kind of getting some bumps, some ups and downs into it. And to do that, I have to push shadow deeper where things are shadow, and I have to maybe bring some extra highlights out. So you see on the wood, you can feel that extra depth and extrusion. Same thing with the stones at the bottom. The one on the left-hand side just feels flat, feels like wallpaper or whatever, just wrapped around the sphere. But the one on the right starts to feel like there's form, volume, and shape to these stones that are kind of poking out. Also, I think the bump, even if it's not, maybe the bump's not strong or large enough or macro enough to really warrant shadows. But in the highlights, you can reveal quite a bit about a material. So on the specular highlights, you can see the scratches or sort of a orange peely, even just a sort of, sometimes it kind of feels like the water that's dried up on your car windshield, and so, or on your rearview mirrors, and it leaves behind that sort of filmy look. Those aren't things that are going to create any shadows, but they will be visible in the specular reflections. So that's a good way to indicate. I mean, if nothing else, indicate material through the specular highlight will get you a lot of mileage and communicate a lot about that material. In general, bump, I'm saying this is inside the silhouette. So we're not actually affecting the outside of the silhouette when we're talking about bump. And so I think that's one distinction I want to make, because in the next one called displacement, we're actually going to deal with breaking outside the silhouette. When we are, these are all tools to communicating material. And so color, bump, specularity, reflections, and now displacement, the actual silhouette of the object. These will all help communicate to the viewer what it is they are seeing. And so you can see the difference on the left and right of both these pieces of wood where I've applied displacement versus not. And I know I've kind of gone a little bit further on this guy with the nails and the kind of like maybe there's planks. But you kind of see even on these, where these dips are on the wood, I've added that silhouette, whereas this is still flat and straight. So when you're trying to really get something up close, or maybe you're doing some viz dev painting, maybe some look of show type paintings, for a prop, and that painting's going to go to the 3D team. They could be an outsourced vendor studio, and you're trying to just communicate as clearly as possible what the final result needs to be. Well, take into account how the silhouette's going to be affected. And, just for this little grass furball I've painted over here, also take into consideration how the silhouette might be affected by that displacement, right? So you can see I've added some kind of grass edges to those shadows. All right, so we've got our displacement. Now let's get into, so it's right here, right? We've done these 1, 2, 3. I've skipped number 3. Boy, I didn't proofread this before I started recording. There we go. Okay, 4, then 5, 6, 7, 8. So I'll have to adjust those. Let's go into the special material attributes. So these are not common, meaning you either are one of these or you're not. I guess you could be maybe a couple of these, and at the same time you could possess anisotropic qualities but also be iridescent. But nevertheless, these definitely do not exist on all objects. Like these first 4, pretty much every object you can find something in one of those 4 categories, but not these ones. Let's take a look at anisotropic materials. Anisotropic, these are really fun. So when I say anisotropic, I usually say they're look for grooves. Where is it being where are lots of little grooves being made? So you can see the vinyl record is a very common, or kind of your quintessential example. But we don't paint vinyl records that often. What we do paint all the time is hair. And hair, because it's just a bunch of, thousands, hundreds of thousands, maybe millions of very, very thin strings, all laying next to each other, and they're actually quite reflective. They're shiny. So you can see the reflections start running across the form. Now, there's a reason why this happens, and if I were to just kind of draw this out for you so you can see, this kind of gives us into the angle of incidence topic. Let's just say I have a material here. Whoops. Let me just say it's blue. Maybe it's a mirror. All right. So as light comes in, if this is a mirror-like surface, it bounces, and it's going to bounce off in the opposite angle that it came in. So this angle and this angle here are going to be the same. All right, so that's just your normal, typical surface that's, flat and reflective. Anisotropic materials, because of the groovy nature, they are not just flat like we just did, and they're going to be more like grooves. So let's just say this is a very microscopic cross section of our hair, or maybe this pipe that's been brushed. Right, so like each one of these would kind of be like a strand of hair. They're all kind of filed on top of each other. So this kind of creates the this lumpy surface. Well, what's going to happen when the light hits that? Well, this light might bounce here, and that's going to bounce off that way. This next light ray can bounce off here, and that might bounce off this way. Then this other light beam, pew, shoots there. Where's that going to go? Out there. And then we have another light beam here, and that shoots there. Okay, so, well, how does that result to the record or the hair? Good question, whoever asked that. What's basically happening, and let me try to draw a new one of these guys out. Let's just say here's our eyeball. The all-seeing eye. All right, when the light bounces here, in order for us to see the specular reflection, and remember specular reflection means reflection of the light source. So in order for us to see this shiny light bulb in this material, the angle of incidence has to be such that it bounces back to our eye. Well, let's just take another light ray here that goes boom. We're not going to see a reflection right there because that one's not bouncing to our eye. But guess what? This next one is going to bounce to our eye. And guess what? Right here, another one we're going to see. And another one. So what we end up seeing is we see a little specular highlight just on that area of the material where the angle of incidence matches our eye. Well, that's microscopic level. Look at this pipe right here, and basically what we're seeing is a bunch of highlights over and over and over again, right? This is that lumpy surface, groovy surface, let's call it. So same thing here, right? So here we have, if I'm just following the contours of each one of these grooves, so when even though the light, say, is just straight above, the angle of incidence is such that it's like, boom, that goes, let's see, here's my eyeball, right? So the light comes in to my eye, there to my eye, there to my eye. So no matter where the light hits, I'm gonna get, I'm gonna be at an angle of incidence somewhere. So anisotropic materials love to kind of show themselves because they open themselves up in terms of angle of incidence to the viewer and to our eye. What I love about hair, and this is very common, you'll notice oftentimes artists get what we call the halo effect. So it's like a little angel halo. Because of the way the hair stems, kind of grows out from here. You can imagine, say for example, this is some bangs, and so we have a face right here. We'll get this nice halo of reflection across there, and it's a nice design. So when you design the lighting properly with the right material, you get some really nice shapes as well, and it really accentuates the form. I guess we're looking almost like the back of a head. That's why I have, even though this is curved the other way, guess what? It's still the right angle of incidence. So, this way concave, or this one convex, or vice versa. But both this angle and this angle are all at the right angle of incidence to our eye as a viewer. All right, so there you go. There's some examples of some anisotropic materials. And even sometimes things that just get a lot of scratches end up having a very similar effect. So take a look at that. All right, subsurface. Subsurface materials are everywhere. but the most common ones are they're going to be painting a lot of is going to be skin, flesh, and wax. Things like grapes, certain animal skins and things like that. There's a lot of subsurface that happens. Now, we call it subsurface, or to be fully accurate, we call it subsurface scattering, because what happens in this sort of material is the light enters, and instead of just bouncing off or being fully absorbed, it actually scatters through the layers of skin or flesh in this example. So as it does that, it picks up more color. So light enters, and because you have a lot of red blood, the skin underneath your first layer of skin is very red and vascular. There's a lot of blood that has to go there. It picks up a lot of red colors. Now, this is not my best hand drawing ever, but you can see that light is kind of hitting the back of this, and you might ask, well, why am I not seeing my bones through my finger here? And you can do this with yourself. Just take your iPhone or whatever, turn on your light, and shine it through the back of your hand. And you won't see the bones, because what's happening is the light enters and it actually scatters around your finger and then out the other side. So the light's not like going all the way through your hand to come out the other side. It's kind of going in and then starts to go around the outer perimeter and then back the other side. And your fingers will glow and your hands will glow nicely. So on these bottom two examples, I have like a wax on the left and a light flesh. And these are both being backlit. With subsurface materials, we actually will often go less than halfway to black because light is scattering into the shadow zones. We'll also end up with softer cast shadows. The shadows won't be as sharp. So less contrast, softer shadows. And I just wanted to give you a couple examples of some different flesh tone colors. When we paint light skin, two things are, one is the highlights will tend to be warmer. So we'll kind of just go ahead and go with, well, not necessarily, we don't have to be, but generally speaking, it's nice to go warmer with that. The other thing we do is on the shadows, we definitely stay more saturated. And white skin or light skin is better defined by its shadows, right? So we get more contrast in lighter objects. We know this. So the lighter the object in the shadows, we have a larger scale to play with, right? So if I had a white object, I have down to here. If I'm going halfway to black, so I have all this real estate to play with, right? So in this flesh tone here, I have there. So I have quite a bit of room to move on the value scale. Dark skin, however, I have way less room. So dark skin is not as well defined by light and shadow, or I mean the Terminator going into the shadow side. It's better defined by its reflections. So here I've kind of reflected some cool light as if there's like a blue sky or something. And this is a great, a great way to pull out the forms of darker skins. A good artist to look at for, say dark African skin would be Kadir Nelson. That's Kadir Nelson. And he's done a lot of sort of black history, African American stories and books about like Jackie Robinson. And he's done some beautiful paintings of dark skin that really showcase how this is done, or some good examples for color choices and how to handle and do the forms. But yeah, so it's just an important thing to realize that darker skin has to be lit, or you're gonna have to take a different approach than lighter skin in order to really maximize the form that you want to show. Okay, so there's our subsurface materials. Let's take a look at some. This is a quick one. Transparent and translucent. So they're two different types, but they're related. Excuse me, I'm yawning a lot because it's pretty late. Transparent we can see through, right? It's like sunglasses, for example, and the image isn't distorted, right? If I'm wearing a light pair of sunglasses, you can, see through and see my eye. It's darker, but it's not going to be distorted or fuzzed out. Translucent materials you can see through as well, but the objects are going to get distorted or blurry. So I wrote privacy because it kind of is like privacy glass. If you've ever seen privacy glass, it's kind of been frosted and you can't see through the other side very well. So if the image is being at all distorted, then we're kind of talking more about translucency. If it's tinting, darkening, or colorizing whatever's behind it, but we can still see sharply what's back there, now we're talking about something that's just transparent. And I think this is an important term to get right, because if you're talking to a 3D artist, this is one of those things where, you need to you don't want to confuse the two. All right. Here's kind of a fun one, iridescent colors. So iridescent materials are defined by the color is going to change or appear to change depending on the angle that you're looking at it or the angle that the light hits it. So in 3D, sometimes we call this the facing ratio, like which way is any part of an object facing to the viewer. So you can see on this left-hand side, as the surface turns away from me, it turns into that magenta color. But as the surface turns and faces me, it gets more of that bluish purple look. So the colors itself are being determined by which way they're facing relative to me. And no matter how I walk around this sphere, the colors are always going to look like this. A bubble is a good example of an iridescent material. What's kind of neat about the bubble too is you can actually, like this, if you study bubbles, they actually do have a consistent facing ratio. So here you can see the pink in the middle works its way out to green, yellows and greens, and then we have pink and then blue on the opposite sides, which is actually a little bit of a stylized choice, the pink and the blue. But what's consistent here is you'll notice that like this shape on the top half is a mirror image of what's on the bottom half, mirror and flopped actually. And so bubbles will do this. They'll actually, you look closely, you'll see that the reflected environment is flipped flipped both ways, vertical and horizontal. And then you apply the right color, iridescent colors to that environment, and you'll end up with a nice bubble look. So here I've sort of designed some random shapes, based on, I was looking at the reference and it was giving me some ideas. So I took those and just I said, I'm not going to try to actually paint what the actual environment is. I'm just going to go for some interesting design shapes that hopefully make it read like a bubble. Some other iridescent, like beetle shells and certain card paints will also, certain card paints can be iridescent. Whew. And that then goes to one more, luminescent materials. So objects that glow, materials that glow. I'm kind of giving you just two key examples here for this. And generally speaking, when things are iridescent, like they're actually emitting light, that means they're not going to take on any form or light or form from the shadows. So don't paint, shadows of any kind on luminescent objects. They are themselves the light source or a light source. So they're not going to take on any light and shadow the way non-lit objects would do. Now the difference you'll see here is the lightsaber on the right is sort of very hot and bright in the middle, and then goes out to a less bright or hot value color. Whereas the blue sphere is sort of darker in the middle, and then it gets lighter around the edges. You'll also notice on the blue one I've lit, instead of a cast shadow on the ground, I put a lit, like the light is actually being lit from the sphere itself. Why go opposite? Light in the middle to the outside darker, or dark in the middle to the outside lighter. It actually kind of depends mostly on how the luminescent material is being contained. Here, the lights on the lightsaber one, it's going from the inside out, and that just looks a lot of energy and it looks cool, whatever. But the blue sphere, it's almost like it's sitting inside of a glass capsule, and so as it gets to the edges, it might be picking up extra light because it's thinner. You're actually looking through a thinner amount of substrate in this instance. And so it could actually just be just a little bit brighter looking. I've also put a slight glow around the outside. All right, now that pretty much wraps up the four all these different 4 common attributes, and then 1, 2, 3, 4, 5, 6 different special attributes. And now it's time to paint. So what I want you to do for your homework, let's just talk about that real quickly, is do 10 materials, right?